Listen to me very carefully. The reality you experience every single day, the solid ground beneath your feet, the familiar stars shining down in the night sky, all of it is hiding a secret so profound and so deeply unsettling that it forces us to completely rewrite what we thought we knew about our place in the cosmos. Just recently, astronomers peering deep into the heart of our home galaxy, the Milky Way, uncovered something entirely unexpected. We tend to look at the night sky as a serene, unchanging gallery of lights, a cosmic tapestry that has remained peaceful for billions of years. But when we build instruments sensitive enough to read the invisible whispers of the universe, the gamma rays, the high-energy particles, and the violent distortions of space-time, a very different picture emerges. I remember the first time I truly internalized the sheer violence and dynamism locked away behind the tranquil beauty of our galaxy. We live inside a swirling disk of hundreds of billions of stars rotating around a monstrous gravitational anchor at the center, a supermassive black hole. But what lies hidden in the dark recesses between those stars is not just empty space. It is a dynamic, restless ocean of forces that can awaken without warning. When you peer into the recent data collected from the deepest surveys of our galactic center, you realize that the Milky Way is not a quiet retirement home for ancient stars. It is an active engine capable of outbursts and structural anomalies that challenge our very understanding of cosmic stability. Something massive has shifted, leaving behind signatures of energy that should not be there under any standard model of galactic evolution. It is a discovery that forces us to confront a sobering truth. 3. The universe does not owe us a comfortable existence, and the quiet neighborhood we think we inhabit is sitting right on top of a powder keg. 3. Before we take this journey together to uncover the exact nature of what is lurking in the dark, make sure to hit that subscribe button and ring the notification bell. Okay, you are going to want to stay with me through every single step of this exploration, because what we are about to uncover will change how you look up at the night sky forever. 3. Imagine walking into the living room of an old familiar house, a place where you have lived your entire life. In the corner sits a massive antique grandfather clock. 3. Its pendulum swings back and forth with a heavy, reassuring rhythm. You set your watch by it. You trust it implicitly. For as long as humanity has been looking up at the night sky, okay, we have treated the Milky Way galaxy like that reliable grandfather clock. I have spent my career studying the deep laws of the universe. 3. And it is easy to fall into the comforting belief that the cosmos operates like a well-oiled machine. We mapped the sprawling spiral arms of our galaxy. We calculated the sweeping orbits of the stars. 3. We know that our own solar system is cruising through the emptiness of space at roughly 500,000 miles per hour, okay? Taking about 250 million years to complete a single majestic lap around the galactic center. Okay, our entire understanding of physics and astronomy on the comforting idea that the heavens operate on predictable, almost mechanical laws. We looked at our home galaxy and saw a mature, a stable city of stars deeply settled into a long, quiet middle age. But what happens when you open the heavy wooden door of that grandfather clock, expecting to see smooth brass gears ticking away, and instead you find a hidden engine burning with the blistering heat of a blast furnace? That is exactly the shock astronomers experienced when we stopped looking at the galaxy with frail human eyes and started using instruments capable of seeing the invisible universe. When you and I look at the night sky, we are only absorbing a tiny, insignificant fraction of the light that actually exists. We see only the visible spectrum, but the universe speaks in many other far more violent languages. It broadcasts in radio waves, it flashes in X-rays, and it screams in gamma rays. When we pointed our most advanced X-ray and gamma ray telescopes toward the very core of the Milky Way, the illusion of our quiet grandfather clock shattered completely. We discovered structures so colossal, so terrifyingly powerful, that they completely defy everything we thought we knew about our peaceful galactic neighborhood. Erupting out of the very center of the Milky Way, blasting outward like two gargantuan geysers of fire, are twin balloons of high-energy radiation. We call them the Fermi bubbles. and their outer shock waves are known as the Arosita bubbles. But giving them a gentle clinical name completely masked their terrifying nature. These structures span an unimaginable distance. 3. They stretch 25,000 light-years above the disk of the galaxy, and another 25,000 light-years below it. To put that immense scale into perspective, 3. If you could drive a vehicle at highway speeds straight up from the center of the galaxy, it would take you billions upon billions of years to reach the edge of just one of these bubbles. 3. And these massive voids are glowing fiercely with high-energy radiation, which is the undeniable signature of matter and particles moving at very nearly the speed of light. 3. This is the foundation of our mystery. These towering infernos of radiation are simply not supposed to be there. Our galaxy is supposed to be dormant. A structure of this mind-numbing size, 3, glowing with this much raw energy, is the direct aftermath of a cataclysm. 3. It tells us that something at the exact center of our home galaxy detonated with an explosive force equivalent to perhaps 100,000 massive stars going supernova all at the exact same time. 3. The sheer scale of this eruption breaks our intuition. But what is even more deeply unsettling is the timing. In the grand lifespan of the cosmos, which is nearly 14 billion years old, 3. This explosion did not happen in the ancient chaotic dawn of time. The fading energy signatures tell us this happened recently. Just a few million years ago, 3, right around Clear's throat, the time our early human ancestors were first learning to walk upright on the savannas of Earth, the center of our galaxy erupted into a blinding, lethal inferno. And now, we have to figure out what pulled the trigger. Imagine looking out your window and seeing a delicate autumn leaf falling from a tree. You know instinctively how gravity works. The leaf drifts down, it hits the ground, and stays there. Now, imagine that leaf hits the ground, suddenly bounces back up, and starts orbiting your roof at supersonic speeds. Your brain would immediately reject what your eyes are seeing. That is precisely the kind of profound intellectual whiplash astrophysicists experienced recently when we pointed our most powerful infrared telescopes directly at the heart of our galaxy, right at the supermassive black hole we call Sagittarius. We have long known that a supermassive black hole is the ultimate cosmic incinerator. Sagittarius A* is a gravitational monster packing the mass of 4 million of our suns into a remarkably small region of space. The gravitational tides near its event horizon are so extreme that they stretch and shred anything that dares to get too close. This tearing process is a fundamental expectation of black hole physics. If a star strays too close, it gets ripped apart. If a cloud of gas drifts in, it gets smeared out into a long glowing ribbon before being swallowed forever in the dark. But the universe has a wonderful habit of throwing us curveballs just when we think we understand the rules of the game. Over the past 2 decades, as our observational technology improved, we started noticing something completely baffling. We spotted dense clumps of what looked like ordinary gas and dust hurtling on highly elliptical, very daredevil orbits right toward the supermassive black hole. The first one we noticed, we simply called G1, and then came another, G2. When we calculated the orbit of the G2 cloud, we realized it was going to make a perilously close pass by the black hole. The entire astronomical community held its breath. We expected a spectacular show. 3. We predicted with near absolute certainty that the black hole's tidal forces would mercilessly tear this gas cloud to pieces, devouring it in a blinding blaze of energy. But that is not what happened. 3. As G2 whipped around the black hole, passing within a cosmic hair's breadth of the point of no return, it did something impossible. It stretched and deformed slightly, yes. 3. But then it pulled itself back together. It survived the passage and continued on its orbit, remaining incredibly compact. This broke our models. 3. A mere puff of gas does not have the internal gravity to survive the tearing force of a 4 million solar mass black hole. If it was just a cloud of gas, it should have been destroyed instantly. 3. The fact that it survived told us immediately that we were not looking at a simple cloud. We were looking at something hiding in disguise. 3. The mystery only deepened as we continued to watch the galactic center. We found more of them, G3, G4, G5, and G6. We found an entire family of these bizarre objects. 3, all masquerading as loose puffs of gas, but all possessing a hidden dense core that holds them together against the most violent gravitational tides in the Milky Way. What exactly are they? 3, we are forced to consider strange and exotic possibilities. We now suspect these might be the bizarre remnants of binary star systems. Imagine 2 stars that peacefully orbited each other for millions of years until the black hole's immense gravity scrambled their orbits, forcing them to crash together and merge into a single blow, a strange star shrouded in a thick cocoon of dust. Alternatively, they might be dense clumps of stellar material being actively puffed out by a massive, fiercely spinning star nearby, acting like a cosmic smoke machine. Whatever their origin, they completely upend our understanding of the galactic center. We used to think the space immediately surrounding a supermassive black hole was a dead zone, a barren wasteland swept clean by gravity. But instead, we are finding a complex dynamic ecosystem. 3, we are finding a bizarre stellar nursery operating under the most extreme conditions imaginable. And here is the most unsettling part of this discovery. These strange objects are actively dropping material into the black hole. They are feeding it. Remember those massive towering bubbles of radiation I told you about? They're the ones extending 25,000 light years into space. Those bubbles are the smoking gun of a black hole that recently gorged itself. And as we watch these G objects circling the drain, we realize we are watching the appetizers being served for the monster's next meal. To understand the true magnitude of what we are facing, we need to step back and look at one of the most fundamental contradictions in modern physics. In science, when 2 established proven facts collide and point in opposite directions, we call it a paradox. And right at the core of our galaxy, we are looking directly into the face of a paradox that threatens to break our models of stellar evolution and cosmic history. I call this the paradox of the sleeping giant. When we calculate the energy output of Sagittarius A today, we find something astonishing. For a black hole possessing the mass of 4 million suns, it is practically asleep. It is operating on what astrophysicists call a starvation diet. To put this in perspective, if our sun were consuming mass at the relative rate Sagittarius A consumes mass right now, it would take centuries for it to swallow the equivalent of a single grain of sand. The monster is quiet. It is dim. In the vast zoo of galaxies across the universe, there are active galactic nuclei called quasars that blaze with the brilliance of 1 trillion stars, furiously swallowing whole worlds. Compared to them, our black hole is a whisper in a silent room. That is the first fact. Now, consider the second fact, which completely shatters the first. Right next to this supposedly dormant monster, within the innermost light months of the galactic center, we find a dense swarm of brilliant young stars. Astronomers call them the S-stars. These are not faint, ancient red dwarfs that have spent billions of years slowly drifting into the center. These are massive blue giants. They burn through their nuclear fuel at a furious pace. They live fast and die young, often lasting only a few tens of millions of years before ending their lives in violent supernova explosions. And that is where the paradox tears our logic apart. Wait, how did those young stars get there? In classical astrophysics, we know exactly how a star is born. You need a vast, cold, tranquil cloud of gas and dust. Over millions of years, gravity gently pulls the cloud inward, allowing it to collapse under its own weight until the core becomes so dense and hot that hydrogen atoms fuse into helium, igniting the spark of nuclear fire. It is a slow, delicate process that requires absolute calm. Now, imagine trying to blow a fragile soap bubble in the middle of a Category 5 hurricane. It is physically impossible. The wind will tear the soap film apart before the bubble can ever take shape. The gravitational tidal forces near a supermassive black hole are the cosmic equivalent of that hurricane. As a gas cloud gets pulled toward the center, the side of the cloud closer to the black hole feels a vastly stronger gravitational pull than the side farther away. That difference in force, what we call tidal shear, will relentlessly rip the cloud into long, thin shreds. It should be physically impossible for a gas cloud to ever collapse under its own gravity, to form a new star in the vicinity of Sagittarius A star. Yet, there they are, glowing fiercely right in front of our telescopes. Dozens of massive newborn stars racing around the black hole at breathtaking speeds. 3. We are caught between two undeniable realities that cannot comfortably coexist. If the black hole's gravity prevents star formation, those stars could not have formed there. 3. But if they formed far away in the peaceful outer arms of the galaxy and drifted inward, it would have taken hundreds of millions of years for them to make the journey. Far longer than their entire lifespans. They would have burned out and died long before reaching the center. This forces us into a corner. 3. Either our understanding of how stars are born under extreme gravity is fundamentally flawed, or something vastly more violent and abrupt happened in our galactic core in the very recent past. 3. Something disrupted the natural order, smashing gas together at such ferocious velocities that it forced stars to ignite against all physical odds. 3. We are looking at a dormant volcano surrounded by fresh lava, and that means the giant is not permanently asleep. It is merely resting between eruptions. 3. To truly grasp the terror and the majesty of what is happening at the center of our galaxy, I need to take a moment and break your brain just a little bit. I want to talk to you about time. 3. I have spent my life studying the deep equations of physics, and I can tell you that most of us think of time as an absolute. We view it as a rigid, a steady tick-tock that marches forward universally for everyone, everywhere. A second for me is a second for you. If you wind up a reliable wristwatch, you trust it completely. 3. But Albert Einstein taught us over a century ago that this comforting notion of time is a total illusion. Space and time are not rigid, empty stages. They are a flexible, woven fabric. Okay? And when you drop a 4 million solar mass black hole onto that fabric, it stretches and warps so violently that the very concept of reality begins to bend. I know this sounds like science fiction, okay? But we know this is absolutely true because we are watching it happen live right now to a specific star deep in the galactic center. We call this star S2. S2 is a massive, incredibly bright young star caught in a death-defying orbit around our supermassive black hole. Imagine driving a race car around a track. Now imagine that track is drawn on a trampoline, and someone has placed a massive bowling ball right in the center. As your car races past the bowling ball, it dips deeply into the depression, accelerating to blinding speeds. That is exactly what S2 does. At its closest approach to the black hole, this massive star reaches speeds exceeding 11 million miles per hour. But here is where the universe stops making intuitive sense. As S2 plunges into the deepest part of the black hole's gravitational valley, time itself slows down. If you could somehow safely stand on the surface of S2 with a clock, you would not notice anything strange at all. Your clock, it would tick normally. You would age normally. But if I am standing here on Earth looking at you through a telescope, I would see something impossible. I would see you moving in slow motion. I would watch your clock tick dramatically slower than mine. This is not an optical illusion or a trick of the light. It is a fundamental law of physics called gravitational time dilation. 3. The intense gravity of the black hole is literally grabbing hold of time and dragging it to a crawl. And we have actually measured this. When S2 made its closest pass by the black hole recently, 3, our team of astronomers watched the light leaving the star. Think of light as a runner trying to sprint out of a steep valley. Because the black hole's gravity is pulling back on the light so intensely, the light has to expend enormous amounts of energy just to escape. As it loses energy, its wavelength physically stretches out, shifting toward the red end of the spectrum. We call this gravitational redshift. We watched in real time as the light from S2 arrived at our telescopes exhausted, stretched, and physically altered by the crushing weight of the black hole's gravity. But the bending of time is only half of the story. The intense gravity also severely warped space. 3. According to the simple laws of gravity Isaac Newton gave us, S2 should trace a perfect closed elliptical orbit over and over, exactly like drawing a simple oval on a piece of paper. 3. But because the supermassive black hole curves the very fabric of space around it, the orbit does not close perfectly. Each time S2 completes a lap, the entire oval shifts slightly forward. 3. Over many orbits, it traces out a shape like a rosette, or one of those spirograph toys you might have played with as a child. This is called Schwarzschild precession. 3. We have tracked S2 long enough to see the entire orbit actually pivot in empty space. I want you to really absorb what this means. We are not just looking at a star moving through space. 3. We are looking at a star riding on a fabric of space and time that is actively being twisted, stretched, and distorted by an invisible monster. 3. The solid geometry you learned in school breaks down completely. In this extreme environment, the shortest distance between 2 points is not a straight line. 3. And the steady passage of time is a complete fantasy. We are watching the fundamental rules of reality being rewritten right before our eyes. And this brings us to a terrifying realization. 3. If the gravity here is so violently intense that it twists the basic structure of time and space while the monster is sleeping, what on earth happens when it finally wakes up? 3. Now we come to the hard truth, the sobering realization that modern astrophysics forces us to confront. For as long as humanity has looked out at the cosmos, 3, we have comforted ourselves with the illusion of permanent stability. We like to think of our Earth as a safe harbor nestled inside a quiet, civilized galaxy that will remain peaceful for eternity. 3. But when you look at the raw physics governing our universe, you realize that the peace we take for granted is not a permanent guarantee. It is merely a temporary pause. 3. I have spent decades exploring the deep architecture of the cosmos. And if there is one fundamental lesson nature teaches us over and over again, it is that equilibrium is always fragile. In physics, 3, when a system appears completely calm, it often just means the underlying forces are momentarily balanced. Think of a massive boulder balanced precariously on the edge of a steep cliff. It looks completely still. You can set up a picnic next to it and enjoy the quiet afternoon, but that stillness does not mean the boulder lacks destructive energy. It simply means nothing has nudged it yet. Our home galaxy is that boulder on the cliff. The supermassive black hole at the center of the Milky Way is not a gentle giant that has sworn off violence. It is an active engine running on empty. The only reason it is dim and quiet today is because it has temporarily cleared out the buffet of gas and dust immediately surrounding its event horizon. But the galactic center is surrounded by a massive reservoir of cold, dense gas known as the central molecular zone. Hundreds of thousands of light years of matter are constantly swirling, colliding, and shifting in the deep gravitational well of the inner galaxy. All it takes is a minor gravitational disturbance, a passing star cluster, a collision between massive gas clouds, or the slow, inexorable inward drift of those strange objects we discussed earlier to funnel a fresh supply of gas directly down the throat of the black hole. When that happens, the giant will not wake up slowly. It will ignite. When a supermassive black hole suddenly consumes large quantities of matter, the gas does not simply vanish silently into the dark. As the material accelerates toward the event horizon, it rubs together at nearly the speed of light. Friction heats the gas to tens of millions of degrees, transforming the quiet void into a blazing accretion disk that outshines every single star in the galaxy combined. The black hole transforms into an active galactic nucleus, a cosmic blowtorch blasting immense relativistic jets of charged particles and lethal high-energy radiation millions of light years into intergalactic space. We know this happens because we see it everywhere we look across the distant universe. We see galaxies whose cores are burning so brightly that the radiation strips away the atmospheres of surrounding worlds and blows out the very gas clouds needed to form new stars. And now, because of the discovery of the Fermi bubbles and the erratic behavior of the gas in our galactic core, we know with absolute certainty that this has happened right here in our own home galaxy repeatedly throughout cosmic history. We exist today only because we happen to live in a very specific sweet spot both in space and in time. 3. We live 26,000 light years away from the center out in the quiet spiral arms of the galactic suburbs, and we live in a brief, lucky window of cosmic calm. If our species had emerged just a few million years earlier, when those towering bubbles of radiation were violently blasted out of the core, the radiation environment of our region of space might have been drastically different. The hard truth is that the universe is not designed for our comfort. Galaxies are violent living ecosystems governed by cycles of destruction and renewal. The calm night sky that inspired our ancestors to write poetry and dream of the stars is a fleeting snapshot of an ongoing cosmic tempest. 3. We are living on borrowed time between eruptions, and the clock at the center of the galaxy is still ticking. When we pull all these threads together, we get the colossal bubbles of radiation towering over the galaxy, the mysterious objects defying the gravitational shredder, the paradoxically young stars defying every law of stellar birth, and the violent warping of space and time itself. A grand and climatic picture emerges. We are not living inside a static, unchanging portrait of the heavens. We are participants in a dynamic, evolving cosmic drama, and the climax of that drama is already rushing toward us across the dark void of space. Right now, as you listen to my voice, another giant spiral galaxy, Andromeda, is hurtling toward our Milky Way at over 250,000 miles per hour. In roughly 4 to 5 billion years, these two colossal cities of stars will begin a gravitational dance that will tear their structures apart. It will not be a collision of solid surfaces. 3. Stars are spaced so far apart that virtually none will physically smash into each other, but the vast clouds of gas and dust that permeate both galaxies will slam together in a breathtaking cosmic pileup. 3. When those gas clouds compress, gravity will funnel hundreds of thousands of light years of matter that directly toward the center. 3. The starving giant at the heart of our galaxy will suddenly be presented with an unimaginable feast. 3. The dormant monster will wake up with a fury unlike anything our region of the universe has ever witnessed. Sagittarius, a star in the supermassive black hole at the center of Andromeda, will spiral toward each other, ultimately merging into a colossal black hole tens of millions of times the mass of our Sun. In that moment, our quiet galaxy will ignite into a full-fledged active galactic nucleus, a blazing quasar outshining everything in the local universe. The tranquil night sky that humanity has known throughout our brief existence will be replaced by a dazzling, lethal river of light accompanied by relativistic jets that blast across intergalactic space. The cycle of cosmic fire will begin anew, blowing away the gas and dust to give birth to a completely new giant elliptical galaxy. When you stand under the stars and contemplate this grand cycle, it changes something deep inside you. It reminds you that we are made of the very stardust forged in these ancient furnaces, carrying the heavy elements created in past cataclysms inside our own blood and bones. We are the universe waking up, becoming conscious of itself, and daring to look directly into the beating heart of the cosmic machine. Producing these deep, rigorous journeys into the deepest mysteries of physics and cosmology requires an enormous amount of research, dedication, and effort. 3. If you appreciate this kind of uncompromising exploration of the cosmos, and if these ideas challenge the way you think about reality, consider using the Super Thanks button right below this video. 3. Your direct support makes it possible for us to continue unraveling the deepest secrets of our universe and sharing them with curious minds all across the globe. 3. Every single contribution helps keep this independent scientific journey alive, and I am profoundly grateful for each and every one of you who chooses to support our mission.